Hey guys, welcome to day 7. Notice it's our second No Inspire Day. If you look at your day 7 packet for your guided notes for today's lesson, you'll notice that you have these very strange looking pictures here. Now keep in mind, math is consistent and everything we've learned to more normal looking parent graphs will apply to what we like to call funky functions. They're funky, they're weird, but they are functions. When you look, they do pass the vertical line test. So any of the transformations we've learned so far can be applied to functions, and any function, whether it's something we've seen before or not. So our goal today is to take something strange looking that is a function, apply what we've learned through the last week and a half or so with our transformations, and see that it's not so bad. We are going to start using colors. I have some colored pens. You may want colored pencils or crayons, just so that you can help distinguish the different steps. So let's focus on this first function. Notice it says the transformations you have learned can be applied to graphs such as this, something kind of strange looking, and its name is f of x. So our goal is to graph the child negative f of x minus 3 plus 2 by breaking the child function down into individual transformations to build to what we want in the end. So math is consistent. Order of operations are consistent. So we're going to follow PEMDAS. We're going to do grouping symbols first, parentheses or any other grouping symbol, and then multiplication, division, adding and subtracting at the end. Here we go. So step 1, let me zoom in to the actual work. I give you the function by itself at the top, and then here on the side. Sorry. I give you the function on the top, and then here on the side, at the bottom, we have the one that will do the transformations to. So here we go. We want to take this parent graph, f of x. The first thing we notice is in parentheses we have f of x minus 3. We're going to graph that first. Well, what we've noticed with all of our parent graphs is when we have a minus 3 in parentheses, that is a translation to the right 3 units. Again, the reason a minus 3 goes right 3 units is because it's like we're writing x minus a positive 3. That positive 3 tells me right. We're big kids, we don't double sign anymore, so we just change a negative positive to a negative. Okay, so I wrote that in red. I'm going to graph it in red. I'm going to take each of the points on my new function and translate them right 3 units. So 1, 2, 3, 1, 2, 3. Now when I translate, shape and size don't change, just location. So this looks curved, your child needs to be curved. 1, 2, 3. This looks curved, curve your child. 1, 2, 3. That looks straight. Child should be straight. And 1, 2, 3. Connect them. So my first transformation was a translation right 3 units. Okay, step 2. Graph negative f of x minus 3. Well, I've already graphed x minus 3. I've already translated it to the right 3 units. So now I'm going to reflect it over the x-axis. We've seen that a negative in front of my function, regardless of the parent, is a reflection over the x-axis. So we're going to reflect over the x-axis. So I take that x minus 3 graph, my red graph, my most recent graph, and reflect it, all of its points, over the x-axis. Well, a point on the x-axis stays put. This point is 1, 2, 3 units away from x, so I'm going to go 1, 2, 3 units away on the opposite side and connect it as if it's looking in a mirror. It's its reflection. This point stays put, connects the reflection. This point, 1, 2, 3 units away, goes 1, 2, 3 units away on the opposite side. And this point is also 3 units away. So I've now graphed negative f of x minus 3. X minus 3 first, because parentheses come before multiplication, and this is like negative 1 times f of x minus 3. So it's a multiplication problem that comes after parentheses. Now finally, the last step, step 3, we've graphed negative f of x minus 3, but now we need to add on the plus 2 at the end. Again, our new transformation is a translation up 2 units. We've seen with any parent graph that plus 2 at the end means move everything up 2. And we're going to take our most recent graph. So I take my blue graph and move all those points up 2 units. And you can start to see why we suggest colored pencils, because it starts to get messy. There you go. And then if you've got, a highlighter or something, it might even help to highlight. I'm limited on my pen colors that'll work on the Elmo device. So it can't hurt either to label your steps. So this red guy is step 1. My blue guy is step 2. And my black guy is step 3. So I can really see. And some people are really nervous because it's so messy and they write final. Not at all required, but whatever makes you feel like I can really see your final answer. And in 1 minute, put that. I'll even take a highlighter and make my final child graph very obvious. Okay, and that's really it. We take any function and we apply what we've learned to it, all of our transformations. So let's try one more on the next page. I give you this function named g of x. Again, this is just a reminder up here that you can read on your own, but order matters. Follow PEMDAS order of operations with our math is consistent. Now, our goal, you can see right here, is to graph negative g of x plus 4 minus 5 by breaking the function down into proper order and graphing each child. So we start with our parent graph g of x. Those will always be given to you. If it's something crazy like that doesn't have an equation. By the way, for extra credits, you might really want to hear this. This is called a piecewise function. Piecewise functions are functions that are pieces put together of a bunch of different things. Here I have a line, here I have a line, here I might have something cubed, or I might have 2 parabolas attached. It's hard to say. It doesn't matter at this point. That's extra credit, extra work. If you're watching the videos, it's bonus for you to know that. So if we want you to do transformations to a piecewise function, we will give them to you. You won't be expected to graph them from the beginning. We'll give you the parent, and you will go through all the steps for the children. Okay, so we have g of x. That's what we're starting with. My parent, or my first child step, is in parentheses. I'm going to graph g of x plus 4. Now, an x plus 4 in parentheses is a translation left 4. Again, because it's saying x minus negative 4. So, we're going to take all the points on my parent graph and move them 4 units to the left. Okay, So I've taken care of g of x plus 4. With PEMDAS, I need to do the -1 times next. Multiplication comes after parentheses. So my next step is to graph negative g of x plus 4. In other words, take my blue graph, my latest graph, and reflect it over the x-axis. All of our reflections to this point are over the x-axis. So just like the last one, you go distance from x, same distance to the opposite side. When I'm on the x-axis, it doesn't move. This guy's 2 away, go 2 away on the opposite side, and connect as if you're looking in a mirror, the reflection. This point's 4 units away. I'm going to go 4 units away on the opposite side. Connect as a mirror image. 4 away, 4 away, 2 away, 2 away, 0 away, stays put, 2 away, 2 away on the opposite side. So there is my second step for graphing this piecewise function. My final step is the -5 at the end. Again, PEMDAS tells me parentheses first, multiply or divide second, add or subtract last. The exponent part tells us our parent graph, so we ignore that for graphing transformations. So I'm going to take my negative g of x plus 4 graph and move it -5, which is a translation down 5 units. I take my most recent graph, in this case my red graph, and I move all those points down 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And so on. And again, you can label them in steps. You can use a highlighter to show your final graph. And that is it for today.